prepared a Retrieval augmented generation powered chatbot using the Google Cloud technologies. I will first explain the architecture, and then I will go with the implemented chatbot. How can you ask the question and all about. So first is the uploading the local PDF documents to the Google Cloud storage bucket. For this, I have this upload to gcs.py, this file. With this file, uh, the documents are getting stored in Google Cloud storage bucket. I have created a bucket, and from there I get that file in the next code, that is file processing, and I processed the invoice document with the Gemini 2.0 Flash. And in that code file I have used a document AI service from Google Cloud. Most importantly, the PDF document was not searchable. I mean, I had to apply the OCR and text extraction via document AI. It was really easy for that. And then to get the structured JSON output from the parsed data, I used Gemini 2.0 Flash with a specific prompt that, okay, this is the uh, parsed data and you need to output all the fields as the JSON key value pair, like this. Yes. And then after I get the JSON key value pair, I stored that the text into BigQuery dataset. In BigQuery there are two things. So one is the dataset, and in each dataset I can create multiple tables. So yeah, I created the table also, and the table name I gave as documents, and the dataset name was contract underscore data, and I can invert that as uh, dataset dot the name of the table. And then I get that data from the BigQuery in the create embedding to create the embeddings. uh, for text chunking, I have used 512 token 512 tokens maximum, because every embedding model has a context length, and yeah, I should respect that. For embedding, I have used the Vertex AI provided. I found this model in the model garden of Vertex AI. This is text embedding 04, and the dimension of the vector was the 768. Then the format of the embedding was the Google Cloud Storage embedding format as the JSON-L format. Then I had to create the vector search index and also the vector search index endpoint, and then I deployed that endpoint. Uh, then I was able to store the embedding in the vector search index. Now the front end part, whenever user asks any question, it gets processed in the streamlit app.py. Then I embed the query with the same text embedding O4 model, and then I do a similarity search with the vector similarity search. I think the my algorithm was the Sparks NN, if I am not wrong. It's not the simple cosine similarity search. Then it find the top three number of neighbors. With that neighbor, it extract the ID of that chunk. With that specific ID, it tries to retrieve the context that is stored in the BigQuery. Once it retrieves the context, then it combine with the context and the answer. It is passed to the Gemini to generate the answer as the endpoint LLM, and then it gives the natural language answer. So this was our architecture. Now I want to explain a little bit about the code. So uh, this is the function to upload the file to the bucket, and Here with the PDF filtering logic, it search that if in my local documents, that is here, all the files that is ending with the .pdf extension, it should just grab that and post in and upload that in the bucket. Okay, I should show you the invoice that I have used for my example. This is the there are many services description and the corresponding amount. Okay, and I specifically filtered for the PDF files because that's the most common format for invoices. And as you can see, this file is not I mean, you cannot select in text, so OCR was applied. Then uh, yeah, this was very small. Then the next code was the Gemini process document.py. uh, yeah, starting from this, I had to write down the some particulars that is needed, the location and the processor ID, bucket name, etc., etc. Then I had to set up the big query, and okay, I created the dataset and table not via the console but by this function. It actually checks the uh, table or dataset has already been created or not. If it is not created, then it actually create with the client dot create dataset. And I have also used a flag that if I want to recreate the table or not. I mean, in production it's not a good practice to recreate and replace all the data, but for the testing purpose I was facing some issues, so I had to recreate once. That's why I use that flag. Next service, once the BigQuery is done, then I get the PDF from the storage client, and then I pass all the PDF in the process document and store in BigQuery. So in this function, the PDFs are getting processed with document AI. You can see here with document AI service client, and whatever the result it gets, then I pass the result to the extract key value pair with Gemini function with the text. And the Gemini client that I have used is also from Vertex AI, not from the AI Studio. And once it okay, I should show you the prompt that I have used here. Yeah, extract all the identifiable fields and values from the document and return only JSON, no surrounding text or markdown. uh, and I try to generalize the prompt in such a way that every I know that the invoices may have different structure and different fields, so generalization was really important for this. And once it return all the fields, then I first saved the JSON in local in the extracted JSON folder, and then I query the BigQuery client, and then I just push or upload the file in BigQuery. This was this much, and then the next part is the creating embedding file. I first show you the main. Yes. uh, yes, so this was the index of the um, of the of the Vertex AI search index endpoint. This was the embedding bucket where the embedding should get stored. So first function it calls is the generate embeddings from the BigQuery. Let's go there. And okay, so at first it queries the BigQuery data, BigQuery to fetch the parsed document, whatever is stored there in the previous document parsing stage, and it gets the data as the rows, found this number of rows. and then it try to embed the data. We first it try to chunk the data in. I think for my invoice it was only 4 chunks because it was too small. And then when the embeddings are done over here, generate the embedding model dot get embedding. It returns the embedding data. Once the embedding data has been returned, then it upload the embedding to Google Cloud Storage bucket. One best practice that I have learned after making this project is to store the embedding, store the text, raw text data, and store the chunk, all everything in the BigQuery itself. Uh, Use only the Google Cloud Storage only for the storing the dumping the PDFs or documents, not for the embedding. It's not the best practice. I know this flaw. I will try to upgrade it to the next level in my next iteration. Okay, so once it uploads the embedding in Google Cloud Storage, uh, it's pretty much done to creating the uh, embedding and uploading to Google Cloud Storage. And then the next part is the front end part, the Streamlit model, Streamlit app. Yes, here it gets the uh, input from the user, and the input should get embedded. So first the embedding also has been done in this function. So query embedding is the embedding model dot get embedding. The embeddings are created here, and with the search response, it searches the vector index in the Vertex AI to get the nearest neighbors. For my case, I have used the 3 nearest neighbors only because it's a very small uh, document you have seen. And once it retrieves the neighbors, it send back the context over here. And once it gets the context, it tries to generate the answer. It gets the context. So you are an expert assistant to answering the question, and given the details, please give the answer. If you don't know, then uh, do not send any answer. Yeah, this front end part is very conventional. Do not need to show anything about Google Cloud. Now I will show you the real answering part. First I will ask what is all about the invoice. Please summarize. The next improvement I will do is the user friendliness, uh, because you should not get the data like this at once. Rather, I should implement a token by token streaming so that user do not need to wait along for getting the answer. Yeah, it retrieves the data correctly. I should ask a specific service, let's say randomly transaction fee T2, give me the fees. I should cross check if it can retrieve the data correctly. Transaction fee T2. So this service, so 0.70 quantity 00. So 0.70. Okay. Yeah, it can retrieve it correctly. Yeah, that's it.